Welcome. In previous video we have discussed Angel-Granger procedure for cointegration. Now we are going to discuss Johansen cointegration procedure using STATA. In Johansen cointegration procedure we assume all variables are non-stationary, their linear combination is stationary. Data which we are going to use, web use, look at POHL, this E at POHL is not there in STATA. And how do we do that? Let's see. Okay, web use. Clear. We have this data. Let's browse. So all set. You have QTR. We'll see the relationship between investment, income, and consumption. First of all, we'll see whether variables are non-stationary. If all variables are non-stationary, then what? So in this case, first of all, we need to set time series data as time series. So quarter variable is already in proper format, so we just declare it to be time series QTR quarterly. Okay, all set. 1960 to quarter 1 to 1982 quarter 4. And no, we just go two-way line so that we have plot of all these three variables, and you can click here, log of investment, log of income, log of consumption. All three variables are upward trending. One variable is missing. Okay, that is basically we haven't defined actually time variable. So we have all three variables upward trending, so there may be trend to be included as well. So first step will be to see whether these variables are stationary or non-stationary, and before that we need to find out how many lags we need. So how many lags we need for log of investment? We need one lag. Okay, and then we apply Dickey-Fuller on ln investment. Trend may also be included. Lags is 1. So this is non-stationary because minus 2.06 is not less than minus 4.06, because this Dickey-Fuller test is one-sided. Here alternative is always rho is less than 1. So now we take var SOC d log of investment. Now we take its first difference, and we see here 0 lag, and we test it. Dickey-Fuller DL investment lags 0, and it is stationary. Okay, it's stationary at first difference. Same process we'll do with the consumption, income. Again we have here one, this FP is suggesting 4, other one this is suggesting as 1 lag. So we'll do here income, and again it is non-stationary. We take its first difference and we apply it Dickey-Fuller. You will see again it will be 0 d log of income. With 0 lag it's stationary. And finally we have SOC log consumption. So we have 4 lags here, so we apply 4 lags. Dickey-Fuller log consumption, trend, lags 4. It is non-stationary. We take its first difference, Dickey-Fuller. Okay, var SOC d log consumption. So here we need 2 lag or 3 lags. Okay, so we just go with Dickey-Fuller d log consumption lags 3. So it is stationary. So all variables are stationary at first difference and are non-stationary at level. Now what? It means now we have to run a basic var model and var basic on all these three variables to select what is appropriate lag selection, and log of consumption and lags 1 to 10. Okay, now we just run var SOC. So we come up that one lag should be selected, or sorry, 3 lags should be selected. So either 1 or 3 depending upon which criteria you are using. So once we have defined it that we have all these 3 variables are non-stationary at level, stationary at first difference, and we need 1 lag or 3 lags. Now it comes that we have 5 equations. We have 5 cases for testing for co-integration. If you go here, co-integration rank of a vector. So in this case, whether include nothing, none. Whether to include constant only in long run relationship, constant in long run relationship as well as in equation. A trend in long run in the error correction, and basically none means no constant either in ECM or in equation. R constant means constant in ECM but no constant in equation. Constant means constant in ECM as well as constant in equation. R trend means that trend in ECM but not in equation. Trend means in equation and in ECM. So you can watch my video on Johansen Cointegration procedure with the equations listed there. So usually we live with this third equation, but first of all, let's say we go with this lag, and we have here log of investment, log of income, log of consumption, and we have either 1 lag or we can have 3 lags. Submit. It may change your results. It may change your results. So in this case, what do we see? That more than this null hypothesis of 0 co-integration is rejected, 1 is rejected, 2 is rejected. So this is 3, and it's not possible to have 3. It means no all variables are stationary. So let's go with the first option, constant, and submit. So in this case, we have, okay, if we take change the lags, instead of 1 we take 3 lags, what happens? So you see, this lag selection criteria is very important and it may change your results. In this case, it seems there is one co-integration procedure vector. So we have come up with an equation that this is your VEC rank, log of investment, log of income, log of consumption. Here what do we say? That we have 3 possibilities. First is none, other one is R constant, other one is constant, the third case where we have, other one is R trend, and final one is trend in ECM and trend in equation. So in case of 3 lags, in case we have 3 lags, optimal lags 3, we see that there is co-integration between investment, consumption, and income. So then we go to the next step, that is estimating whether variables are weakly exogenous. If someone is weakly exogenous, what happens? Or if you have some other constraints as well, so you can estimate Wacom models and all that. Thank you for watching. Take care. My next video will be when some variables are stationary, others are non-stationary, then how to apply ARDL procedure for co-integration. Thank you for watching. Take care.